Hello audience, I'm Verina, Dione, Nanlohy, and for 15 minutes ahead, our team will take us to a fascinating journey about such process that is anodizing and coloring aluminium. Indeed, we did some research and also experiments to comprehend our three main points, which we will emphasize later. That is, to learn the process of aluminum plate anodizing by acidic solution as an electrolyte, to determine the effect of anodizing period over electricity efficiency, and to learn the process of anodized aluminum plate coloring. Anodizing is a passive electrolysis process of a metal inside acid solution that is used to increase thickness and density of oxidation film above the metal surface. As we can see on the picture, the metal that's meant to be anodized is placed in the anode, whereas the metal that's going to form oxidation film placed in the cathode. In our experiment, we use lead metal as the cathode, aluminum plate as the anode, and sulfuric acid as the electrolyte. The result of the anodizing process is the form of oxidized aluminum film known as aluminum oxide. As you can see in the picture, the film form looks like small pores that varies from 10 to 30 nanometer in diameter. And why we have to going through all this simple yet complicated process? It is to enhance a metal's durability over corrosion, deterioration, and increase its ability to absorb coloring substance, therefore create a high-quality industrial products. There are several factors that affect the anodizing process. The first one is acidic solution concentration, who works as a conductor in aqueous state by reducing the resistance along the aqueous media. The higher concentration of a solution, there will be more ions to transfer electricity current from anode to cathode. The next one is electricity current. Current defines number of electrons transmitted over 1 second, that means higher current transfer more electrons within the same period of time, therefore thicker film will be formed. The next one is temperature, which needs to be maintained at a low value to prevent local heterogeneous heating that will damage the film. The next one is type of electrolyte. Electrolyte who can donate 2 protons will have higher efficiency and thicker oxidation film over the electrolyte that only donates 1 proton. The last factor is period. The longer an anodizing process occurs, the thicker an oxidized film will be formed. Anodizing process indeed has its own advantage, such as its ability to extend life of material, maintaining the color stability of the material, providing a side of material such as glossiness, producing an eco-friendly substance, and low maintenance treatments. There are a few of common products that can be produced from anodizing process, such as aircraft component, electrical component, and automotive industry and accessory.
The material we use in our experimental such as sulfuric acid, coloring substance, aluminium plate, water, and sodium hydroxide. And the equipment we use such as anodizing equipment set, drying oven, digital analytic mass balance, digital thermometer, glossimeter, microscopic camera, sandpaper, and many more equipment. How our experimental procedure work. In our experimental, there are many procedures, which are how is the anodizing process, how is the coloring and sealing aluminium, metal process, and the last, how to determine the efficiency of using electric energy during anodizing process. The first procedure is how the anodizing process. The first step in the procedure is mechanical treatment of aluminium metal. In this step, we scrape the aluminium metal and give the initial shape of aluminium metal in size 3-5 cm. The aim of this step is make it simple before anodizing process. The next step is degreasing. What is the degreasing process? Degreasing process is similar like cleaning process, but in this process, we first dipping the aluminium metal into the sodium hydroxide in 10 minutes. Why? Because we need to clean the aluminium from dirt like the oil and grease attached to aluminium. The sodium hydroxide able to dissolve oil because organic salts are formed which have hydrophobic and hydrophilic groups is an oil that has been converted to a water-soluble salt. And then after dipping the aluminium in sodium hydroxide, we clean it by water. The next step is the smoothing. After the aluminium dip in the sodium hydroxide, the aluminium metal is dipping again in the phosphoric acid solution. Has been heated at a temperature 50 degrees Celsius for 10 minutes. Why? Because we need to remove scale and oxide formed on aluminum metal surface and then clean with water again. The next step is racking. What is the racking process? Racking process is arranging the workspace on special shelf to facilitate the anodizing process of aluminum metal in order to obtain homogeneous and optimal result on each workspace. In this process, we wrap the aluminum metal with a wire that would later be attached to the anodizing equipment set. The next step is anodizing process. What is the anodizing process? Anodizing process is growing pore-shaped tube or dip and pipe on the surface of the aluminum metal using an acid solution and the flow of electric current. In this process, we use a PB-shaped metal plate as a cathode, while aluminum is used as an anode. We use sulfuric acid as electrolyte solution. We use this solution as electrolyte solution because 1 mole of this solution can donate 2 mole of H plus ions in the electrolysis reaction. This greatly affects the conductivity value of the solution. The greater the conductivity value of the solution, the smaller the resistance so that the energy need for the electrolysis process is getting smaller. Okay, this is the first procedure. The next procedure is coloring and sealing aluminum metal. The first step in this process is clean anodized aluminum metal with clean water. The next step is preparing the dye solution by dissolving 5 grams of anodizing dye into 50 milliliter of distilled water in volumetric flask and stir the solution of the dye solution until homogeneous, and then pour the dye solution into 500 milliliter beaker. After that, insert the anodized aluminum into the dye solution for 1 minute. After that, leave the aluminum metal after 1 minute and wash it with clean water until the dye does not dissolve again with water. And then, observing the result of the aluminum metal included the texture, color, and glossiness. After that, we do the sealing process. Sealing is the process of closing the pore hole by forming a transparent metal oxide. In this process, we put the colored aluminum metal in boiling water for 3 minutes. After that, we observe again the change in aluminum metal coloring that occurs the same way before. After that, we record the phenomena that have been observed.
The last procedure is how to determine the efficiency of using electric energy during the anodizing process. First step, we use a thermometer to measure the temperature of the electrolyte before and after anodizing at any variation of the electric current in the anodizing. And the next, calculate the electrical energy used. And then, calculate the amount of energy released during the anodizing process. And the last, calculate the energy efficiency along the anodizing process in each time variation. The data that we got from the experiment are environmental data and observation data. The environmental data that we got for group 3A are 48% humidity, 760 mm mercury pressure, 29 degrees Celsius air temperature, and 27.8 degrees Celsius water temperature. The observation data are 0.5 molar sulfuric acid, 6952.902 ml solution volume, 60 minutes anodizing period, 3 times 5 cm aluminum size, 22 volt on 1.5 ampere, and 22 volt on 3 ampere. This is the data that we got from the experiment for initial weight, weight after acidification, weight after anodizing, electric current, initial temperature, and final temperature. This is glossiness data before and after sealing at any variation of the electric current. The environmental data that we got for group 3B are 48% humidity, 760 mm mercury pressure, 29 degrees Celsius air temperature, and 27.8 degrees Celsius water temperature. The observation data are 0.5 molar sulfuric acid, 6576.2959 ml solution volume, 60 minutes anodizing period, 3 times 5 cm aluminum size, and 21 volt on 1.5 ampere, and 21 volt on 3 ampere. This is the data that we got from the experiment for initial weight, weight after acidification, weight after anodizing, electric current, initial temperature, and final temperature. This is glossiness data before and after sealing at any variation of the electric current. From the data that we got, we can calculate the water mass, electrical energy, energy loss through heat, heat energy loss, and percent efficiency. This is the formula and the result for group 3A. This is the result for group 3B.
Discussing about our analysis on the experimental result. Time and electrical current is the major factors toward efficiency. From our experiment data, the higher current has higher efficiency due to the less energy formed into heat. Comparing experiment result between group 3A and group 3B, we can see the longer anodizing occurs, the lower efficiency will be. This phenomenon occurs due to the fact that the oxidation film gets thicker by time. The thicker it gets, the higher the resistance will be, thus resulting in lower efficiency. Second of all, glossiness and coloring. 1.5 ampere has better glossiness over 3 ampere operational condition. It is because the amount of current means more electron travels in a period of time. Theoretically, this means more aluminum molecule is transferred from cathode to anode, making aluminum oxide is formed way faster in 3 ampere over 1.5 ampere. Due to the rapid aluminum oxidation formation, automatically the film couldn't level as smooth as the 1.5 ampere operation in the metal surface. Uneven surface tend to refract rather than reflect light that hits the surface of the metal. That's why 3 ampere operation has less glossy value than the 1.5 ampere. This unleveled film of aluminum oxide has known to cause bigger pore diameters in the anode surface. For an identical metal sheet surface area, if one has bigger pores than the other, means less number of pores formed than the number of pores formed in another metal sheet with small pore diameter. Smaller number of pores means less surface area. This reduces its ability to absorb coloring substance. This theory depicts how 1.5 ampere has a brighter color. Few anomalies that happens in our experiment are a negative efficiency. Operation at 1.5 ampere results in negative efficiency might happen to a misplaced thermometer. Researchers often left the tip of the thermometer on the bottom of the tank. This causes the temperature reading is higher than the solution's actual temperature due to the inhomogeneous temperature of the solution. Our second analysis is caused due to an external heat radiation from direct sunlight. Third, it might be caused by the fact that the thermometer hasn't been calibrated yet. Fourth possible factor is limitation for literature of sulfuric acid heat capacity. In this experiment, we assume that its heat capacity is equivalent to water's heat capacity. Second anomaly is sealing process decreases glossiness. Sealing processes are meant to create a hardened mineral known as boehmite. This mineral is very hard and has a transparent color. It is done to fill on some pores formed through anodizing process and expected to increase the glossiness of the surface. In this experiment, some of the samples didn't show up as what to be expected. This may be caused due to the inaccuracy when calibrating the glossimeter. Other error that might happen is imperfect pretreatment. This causes a lot of impurities and stain to be left on the surface of the metals that are going to be anodized. This will eventually affect the resistance in the electrical current. So, in conclusion, anodizing is a process of creating an oxidation film above a metal surface which require an electrolyte solution as a conductor. This film layer could prevent the inner metal from corrosion and deterioration. The longer anodizing occurs, the thicker the oxidation film will be formed and a higher electrical resistance. Coloring substance will be absorbed by the oxidation film formed previously through anodizing. Thank you for listening to our presentation and have a great day.